Okay, so we got a question right here. Determine the average current in the circuit between the time 0 to time 30 seconds, right? So time 0 to time 30 seconds. Let's see. At time 0 we know that our volt is 6.2, right? Our volt is 6.2 at time 0, right? Time 0 seconds, and our volt at is 1.8 at basically 30 seconds, right? Remember that. You can get it from the graph, right? I got it from the graph. So I'm gonna use the formula, which is to get the average current is I is equals to Q by T. Now I can see I don't have Q. I have to find Q, the charge, right? So charge, I know the formula for the charge is basically, I'm going to use the capacitance formula, right? The capacitor formula, which is Q is equal to CV, right? So I can get the charge from CV. I've been given capacitor value. I have the volt value, but it's delta volt, the change in value in volt, right? So you have to minus them up as well, right? This is my first, right? So you have to find the total charge, that is means the total charge on it, right? So my C is basically 2.2, and this sign basically represents 10 raised to power minus 6, right? So 10 to the power minus 6 multiply with the V, that is given 6.2, and then you have to subtract it from this, right, from the 30 seconds, right? So it's 2.2 times 10 raised to power minus 6, and then you times it by 1.8, right? So you get your value as 9.68 times 10 raised to power minus 6, because you need the charge between the 0 to 30 seconds, right? That's why I subtract these both to get the charge between these value, right? So coulomb, right? Don't forget to put your sign. So this is coulomb. Now I will input this value over here. So my I is, I have to find the I have been given charge as 9.68 times 10 raised to power minus 6, and you just divide it by basically the time, which is 30 minus 30 minus 0, which is 30 minus 0, right? So you get your current as 3.2 times 10 raised to power 7 amps. So this is your final answer, and basically I can see this is in one decimal place, right? According to the question of when you see the capacitor value, the capacitance of the capacitor value, you see this is in one decimal place, right? So that's why I put one decimal place answer for current as well, right? So this is your final answer.